Good afternoon. Welcome to today's Liftoff webinar, brought to you by LIFT, the National Advanced Materials and Manufacturing Innovation Institute, where we drive American manufacturing into the future through technology and talent development. LIFT is a public-private partnership where we convene and connect government, industry, and academia in the fields of advanced materials, manufacturing processes, systems engineering to enhance America's manufacturing competitiveness, national economy, and national security. Thank you for joining today. My name is Christine Longroy, Senior Director of Industrial Base Engagement, and it is my pleasure to introduce our today's presentation, which is brought to you by AT&T. So I'd like to welcome Gillen Young, who's the National Practice Director of IoT Solutions, where he's going to be presenting Enabling the Digital Future and exploring the current state of wireless technologies and its use cases. Take it away, Gillen. Thanks for joining us for this very important topic. Digital's everywhere, so we look forward to your time together. So thanks, Gillen.
Thank you, Christine, and welcome everyone. It's a pleasure to be with you today. Hope that over the next few minutes, we'll be able to share some concepts of things that we see that'll be meaningful in this whole world that we live in. We're focusing in particular on digital technologies. If you think of the title, we said enabling the digital future. We're going to be specifically talking around the current state of wireless technologies. Many of you mentioned AT&T. You'll probably think of, cell phones and cell phone plans, network connectivity. Some of you might think about the, Alexander Graham Bell and that first phone call almost 150 years ago. We certainly have been in this area of connecting people for quite a long time, and I think that leads into the theme of why this digital future is so important and why we need to be thinking about the technologies behind it. Is our current marketing tagline, connecting changes everything. When you reflect on our history, that first phone call, the first cell phone calls and network that was made, the connecting people, connecting businesses, it has changed things. And it's even more important today as we go through and make the investments that allow us to keep advancing the technologies. And while we, cell phone coverage, network capabilities, it's like the light switch on your house. Every time you turn it on, you expect it to be there. And as we look at things across how you're using this, there's things that companies need to be aware of what's coming in the future. So that's generally what we're talking about today, focused on wireless technologies in particular. And I'll share a few comments at the end just about things that AT&T is doing in particular. Wireless technology is one of these things you don't really see. You maybe see the effects when your connection is slow or you don't have a connection. But the reality is there's a lot of technology that is behind it. And as you go through and think about that slow connectivity, slow speeds, or not getting a signal, it all boils down to physics behind it. It's based on the radio waves and the differences in those. And this diagram tries to show at a real high level what we think about, so whether it's the sonar from a sub that can go, across the ocean, or the high-speed radar systems or Bluetooth or GPS, they're all communicating somewhere in this wireless spectrum that includes the low frequencies, infrared, visible light, all the way up to X-rays and gamma rays. And as you see here, all wireless communications are happening in that box you see there, from roughly that 3 kilohertz range up to the 300 gigahertz range. And so as we think about where this is at, and I'll have a slide that talks a little more to this later, there's all the marketing pieces that go into say, 5G this or LTE that. At the end of the day, everybody operates into some of this spectrum, and that's what provides the features of the connectivity. So if we touch on that a little bit more in this next one, and what are the really three core components that spectrum dictates? It's going to drive the speed, it's going to drive the range, and the penetration, how far that signal can go. And if you look at this next slide, this is a good way to look at it, in particular with cellular bands. And you're probably familiar, you'll hear about 4G LTE. You may be hearing about other things, 5G and millimeter wave, even Wi-Fi and CBRS. But this diagram just roughly helps you equate to what the physical properties are around that distance. And it's about how far a signal can travel. So the higher the frequency, the shorter the distance. And so 4G LTE has been out. That has, great coverage, great distance. Mid-band is similar, not quite as far, but then you get into the higher bands, which includes Wi-Fi and what we call millimeter wave, and the 5G spectrum gives very high speeds, but it doesn't travel as far. And that comes into what you have to consider if you're wanting to implement wireless in your manufacturing operation, or if you're doing something in a broader space, farms, for example, or been on auction, car businesses that auction, and they have 120 acres of cars, a lot of area to cover. Those are all considerations that you have to think about. So spectrum frequency drives how far that signal is going to go. And there's this relationship here that this diagram roughly shows. There's trade-offs. High band, you get limited coverage, you get a high capacity, very low latency. The lower bands in that, you get much broader coverage, but you have also lower latency and lower capacity to go through. And so these become very important considerations if you're needing to have applications that, for example, are using video and wanting to capture real-time video. That takes a lot of capacity. So how do you plan the right coverage and the right wireless technology if you're needing to space that out? There's another piece in the spectrum area that does come into play. And there's basically three types. There's the licensed spectrum. That's what AT&T will go out and purchase when it's auctioned by the federal government. That's the same thing that T-Mobile and Verizon go out, and some other providers that go buy the spectrum in that our cellular services leverage. The other end of that is the unlicensed spectrum. That's free. All right, Wi-Fi is an example of that. We'll see it a little bit more detail in just a moment. There's also this area in between that's a shared spectrum, and we'll talk a little bit more about that because you may be hearing the term, in the, private cell networks or CBRS space. Those are some new technologies and new offers that fit certain use cases. But if you look at it, the licensed spectrum, AT&T, Verizon, T-Mobile are the main owners of that spectrum. We have certain frequencies that we operate in. There are some other owners of spectrum that you see here listed, Dish and US Cellular. In fact, I think somebody just bought, I think Verizon just bought US Cellular recently. But, that's where, cellular is going to operate in that licensed spectrum. I mentioned the unlicensed space. You have Bluetooth, Zigbee, LoRa, are all examples of that, along with Wi-Fi. That's what we mean in the differences between that. Now, what is interesting here is in that shared category. And this is one of the newer pieces coming out called CBRS, and it stands for Citizen Band Radio Service. And if any of you out there were like me in the 70s when I was growing up, really wanted one of those CB radios to be able to talk to my friend across town, right, over the airways. It's literally using that service and that frequency. And you see, AT&T, Verizon, T-Mobile, we all have plays in that area. You have new providers like Salona and Betacom and others coming into that. You've also got equipment makers that are doing things in that space. So a lot of options here, but there are certain limitations, and we'll try to show a little bit around that. But if you look at those things, the frequency, the higher the frequency, the greater the distance. Excuse me, the lower the frequency, the greater the distance. Um, but the higher the frequency, the more bandwidth you have, the more data that can go through. But also, the higher the frequency, the less penetration you have in being able to go, deep into a building. And I know some of our challenges, for example, an elevator company that may have some equipment in the bottom of an elevator shaft may have some challenges getting a cellular signal into that space. So there's a lot of options you can consider, but these are literally limitations based on the physics of the radio waves that form the communication. So with that as a basis and starting, let's talk about what's next. All right, that's where we're at today. And if you think about Wi-Fi, there's been in a little over 26 years of this evolution. If you see, starting back to 1999, and you see this progression of technologies over these years. Um, Wi-Fi 2, Wi-Fi 7's out today. Wi-Fi 8's going to be out sometime coming up. They all have different properties, different advances in the technologies. But one thing to point out here to make sure you understand is in this space, it covers certainly business and consumer. The technology changes much faster than I think my opinion in the cellular space. You see these new standards coming out every few years, and so you make investments today. Are you making an investment in Wi-Fi? Wi-Fi 5, Wi-Fi 6, Wi-Fi 7. Those are choices that have to be made. Most businesses probably are out have made those commitments and investments in Wi-Fi 6, but the end of 24 is when we saw some of the official approvals of Wi-Fi 7 and already talking about Wi-Fi 8. So those are just considerations, because if you're outfitting, a 250,000 square foot plant, it's not cheap to go out and install the access points and change them out every few years. So those are considerations. If you look, Wi-Fi 7, which is really just coming into the market now. This shows some of the differences. Again, it gets into the channels and which spectrum it's operating in. There have been improvements to this, so certainly for some streaming capabilities and congestion in the network, maybe some improvements there. Although I'm not hearing a lot of companies that are really making that move, making the big investments yet, in part because the standards have just been officially approved. Although products that have been Wi-Fi 7 compliant has been out on the market for probably a year and a half. Well, Wi-Fi technologies have changed. Likewise, cellular technologies have changed. And if you want an interesting fact for a party where you're needing some off the wall, tidbit of information, the first cellular network in the U.S. was in Chicago, brought by AT&T right before we had the big divestiture. But it was in Chicago, and it came online in 1983. Now, it wasn't when the technology evolved. The technology was developed actually back in the 40s. But the first cellular network in the U.S. was in Chicago in 1980. Of course, the phones looked a little different then compared to what they do today. Found some real interesting history pictures in our archive showing the team that brought that first cellular network to life. But as you see here, there's been an evolution over time of cellular as well, as we moved out of the analog case into digital in the 90s. mobile data in the 2000, and one of the major factors that really brought cellular, made it the staple of everyone's life day in day out was the iPhone when it was launched in 2007. There's some real interesting history around AT&T. We were the exclusive provider of the original iPhone and had an exclusive agreement, but it caught everybody by surprise by the amount of data that suddenly was being consumed on the network. And so a lot of technologies then had to move into LTE in particular in 2010s, uh, to support that higher demand. Um, we're in the 5G world today, and we're seeing the enhancements. And so really the core of 5G, the benefits around latency, reliability, and around speed is what makes the core of 5G. Now, you may hear a lot about 5G, and I referenced this just a moment ago. 5G really is the generic for the low band piece, and this shows roughly how the three major mobile operators in the US, what they call their different products, if you will. So if you see 5GE, that's sort of our extended 4G LTE network that has some added features in it. If you have an AT&T phone and you see a 5G plus, it means you're actually connected to our millimeter wave antennas, giving you that much higher bandwidth and throughput. Likewise, Verizon has what they call their nationwide 5G and their UWB, which is getting into the higher frequencies and higher spectrum. So at the end of the day, each company and their marketing team is going to be putting their spin on how do they promote their products, but it really drives back to the spectrum that's used and what the antennas and the radios do, um, to transport those wireless signals. So that's 5G today. Likewise, what is coming? Yep, there's a 6G coming. A lot of research, a lot of trials that are going on right now. The things we hear about, theoretical peak speeds of over a terabyte. Yeah, I'll believe it when I see it. Um, what's the technology that's going to be driving that? I know in some of our work, and things, I have seen speeds upwards of 2 gig on my personal iPhone, but that's leveraging the higher end technology, specifically with millimeter wave. So purpose here is say it's coming. It's going to be probably more in the early 2030s before you start seeing something commercially. But like everything else, it is, there's groups actively working on that. AT&T participates in that, and developing the standards, as we have been involved with all of the releases for the standards. So that's the public space, the licensed spectrum. There's also something new that's getting a good bit of attention, especially in the manufacturing area. And you may hear the term private cellular networks. So in general, and I believe it was around 2015 or so, the federal government, um, FCC, approved the initial release of doing some work using this literal CV radio frequencies to start communicating and building out a private network. So you see the diagram still using many of the same technologies, but it's using that different spectrum. Um, the privacy, radio design, having some visibility. There are use cases where it may make sense for that, but there's also some limitations. And so that spectrum that's used, it's a 3.5 gigahertz called band 48, and there's a limited amount, that 150 megahertz is used. And this tiering is really important if you're considering CBRS. Um, that top priority is protected. And so if you live anywhere near a naval base, just be aware that a Navy ship's radar gets priority. So if you had a CBRS system there and a Navy ship comes by, you might be without your service for some period of time as that ship goes by. That's That's just the way that spectrum is allocated. There's the lower level, general authorized access, okay? Um, unauthorized, or excuse me, capacity not guaranteed. There's no interference protection. Again, think of your original CB radios that are actually still able to use that frequency. So the part that most people then are using when talking about when we work with building out a CBRS, a private cell network in this space, is that tier 2, where you can get a license. Um, this the It's allocated geographically, but you split up that spectrum, and if you're the only one in that area that's applied for it and want to use it, you can use that space. But the megahertz space drives how much bandwidth you're able to consume. If you have two people wanting for part of it, you may be splitting that up. So it is managed at that level, and so you're having to share that frequency, but it's specifically for that site. So it brings some new options, and one of the pieces that we see some good use cases is, in general, the cellular technologies like this are able to transfer a signal uh, from one radio to another more smoothly than what you can get when you're moving from one Wi-Fi access point to another. We've had work with a number of customers that had an automated vehicle in their facility that was dependent on a connection to the network, and so they had Wi-Fi, and they found that they would stop, mid-route because they lost connection. And so cellular, whether it's the licensed spectrum or the CBRS spectrum here, offers some advantages that should be considered as we're trying to automate more and more. And so that gets back to, why is this important? Well, you got more and more vehicles, more and more use cases of trying to pull this together and make use of it. So that probably leads us into to our use cases. All right, let's think about for a moment. Um, this particular slide came from some of our cellular network engineers, and we think a lot about how you piece the middle, the transport together. All right, so you've got devices on one side, you've got content on the other, and we put a lot of emphasis together as to how it moves from that remote site to its destination. Our group, we're part of a team that does end-to-end solutions, and we look at the world a little bit differently. And so if you look here, we know that out on that edge somewhere, you're going to be acquiring data. You've got hardware out there. You've got to receive messages and push them out. You may have to receive some messages coming inbound and life cycle things. So this framework allows us to explain a lot of decision points across a solution. And part of that is knowing, what are you trying to evolve to in the end? Because, a solution is much more than just providing the transport in between. And AT&T is really good at providing the transport, but that's not going to solve a business problem. You need to be receiving information and making decisions with it, taking some action with it. And that's what we try to come together and talk about as, you know, adding the ultimate value is in solving the business challenges, not just providing all the right transport that's needed to get it. It's important, and yes, there's groups that are very much involved in managing your network infrastructure, but our team in particular focuses on the end-to-end result, which we do. If we move forward, then what are the use cases that we see today that drive, in particular in the wireless area? We're going to touch on a few of these and share some thoughts and ideas from things we're seeing, but if you look here, certainly asset tracking and video is playing a big role. AR, VR, AI. A lot of these are just new areas that put new demands on your network. So let's talk first about some video compression. Um, we see a growing number of use cases, especially in at the state and local level, that's needing to provide video surveillance in remote areas. And so, how do you then collect that video stream in remote areas? Well, cellular becomes a great technology to do that, but cellular video on cellular requires a lot of bandwidth. And so we have partnered and have come up with some approaches and some solutions that basically, I want to see if this will play for me. Yeah, hopefully you can see this, but it's some very unique compression that's being used to compress a cellular signal as it's moving, as opposed to uncompressed video. And so if you look at the top, it's lagging. There's latency. You're getting this jumbled view, and I'm assuming that this is that is coming across um, the
Yes,
screen correct.
yeah, we do see it.
You see it? Okay. And the short answer here is you're able to take gigabytes of video streams and compress it into kilobytes to move it from that remote camera across the cellular network to the end result of what you're going to do with it. AT&T is interested in that because that helps reduce the load on our network, on our cellular network. Because as I said, we're all sharing that frequency, and there are limitations to how much data can be transported. Right? If you were ever in a concert or a football stadium, baseball stadium where there's a lot of people, they're all trying to connect to the cellular network at the same time. And so in years past, when you were relying on 4G LTE, that technology had certain limitations. You had to have the radios, the bandwidth, the throughput. Well, all that's going through a cellular network, so you can clog it up. When you put video on it, it's even taking more bandwidth. So naturally, we were very interested from a how do we solve problems to provide that video service, but also benefit and not not degrading the service for other users of our cellular network. So compression is key, and some things that we're doing. If you look at it, the features across, um, getting multiple video streams coming in. Yes, we can. This technology can be used on other non-cellular, so wired and Wi-Fi as well. But it is, as we see more and more uses of video being used, video as a sensor in particular. So um, capturing more streams, multicasting, remote control of the cameras. Those are all features that this compression allows us to make better use of those assets that are remote. Now, related to video is around the analytics side. And so when you have video streams, that gives you one level of information to see things. Starting to use AI to recognize things coming from that video stream is an emerging area that we see a lot of people wanting to do more with. So this example is a safety, or workers complying with the safety requirements for vests and goggles and hard hats. We're doing some interesting things, for AT&T and for many others. Copper theft is a huge issue today, and we're actually implementing a lot of some of these newer technologies at our cell sites, and have had some interesting results in capturing and actually preventing thefts of copper from a cell tower. And so that's, again, as we continue to leverage video with AI and making sure we get the streams, across from those remote locations, there's just a lot more that you can do with that. So, um, you know, take the images. If you ever wonder what's involved in this whole video analytics, you have to have the source, you ingest the images, you train the model, and then you got to transport that and then take some action with it. So that's where our team is starting to do a lot more in this area of helping design solutions. Got conversations going on today in manufacturing to take some existing video streams that are coming in and apply this new technology to it. We see a lot with traffic monitoring and integrating um, that video analytics into your traffic system for municipalities. We're seeing some interesting things else also in the factory. Cameras on robot arms that are starting to eliminate visual inspections by humans. These are all things that can be done, and helping with the shortage of labor that so many manufacturers um, talk about, having impacting their businesses. So one of the key points, and stress this again, video is a great application, but it consumes a lot of your network capacity. So hence, coming back, talking about video or talking about why wireless is important. It gives you a lot more options for where you place cameras, but understanding that it does have an impact on your network. Likewise, augmented reality and virtual reality are another great technology and has tremendous opportunities for us, but it it has an impact. It's got to get its data, and you see a lot of things are connected. The worker, healthcare, consumers. We're doing things in all of these areas, but um, whatever the use case is, there could be an impact on your network. And I've seen this happen with some manufacturers where they have a great application that might use AR VR and they test it, but when you start, putting multiple headsets out that have two-way video, live video communication back and forth, other applications are degraded because the bandwidth on that wireless network in a plant is suddenly being consumed by these AR, VR applications. So caution on that, just as part of it, of things we're talking about. So um, inspection and maintenance, that one of my colleagues, Scott Carter, um, leads our area on that. And so looking at what you can do, um, there's tremendous opportunities, but it does come. There's some complexities in doing that. Communication is one, finding the tools and making the right investments, because everything may not warrant the effort to build the types of models that you're seeing demonstrated here. One other area that we see questions around security, and in particular, how do you secure how do you secure equipment that is built by a third party in your plant site? And if you think here, original equipment makers build it, they sell it to a plant, but they may need to come in and connect to it and remotely access it so that they are built, they're not having to make a service call on site. Well, we are building worked with one of our partners and building out a new offer we call Equipment Link that is leveraged off some technology that's used in the semiconductor market today. In fact, it's used in about 98% of the plants. And it's basically a private network where the OEMs can connect in and then take care of authentication and authorization into that. And then at the plant site, there's a on-prem server there and hardware that adds additional security and gives you very granular access to that particular equipment at the site. So something new here, we think there's a need in this area to, as more and more automation takes place, you need more and more remote access in to look at potential issues when something's not working right. So that's this is something exciting that we're bringing out to the market, and probably have seen more on that next year. We actually Lyft is one of our demonstration sites, and we've been up there working to connect some of the equipment there in the Lyft factory floor area to help demonstrate this. So hopefully we can share more about that as we get a little further in that deployment. But this solution gives you remote access to the tool, remote secure shell into the operating system if that's what you want, being able to transfer updated files to it, um, and have it screened and security checked. So very granular access that is logged. It just we don't see other solutions out there that go to this level of detail, and it's why we're interested in bringing it out. I think last area that I'm really going to spend some time talking about here is asset tracking. We see that happening a lot. There's all types of asset trackers today, large and small. One of the more interesting ones that we see is related to what we call a smart label. And this is a picture of what it's like. It is a temporary use device. It's disposable, but when it's activated for important cargo that you're wanting to track, it's going to give you location, temperature, humidity. It can detect shock, so it can help when you're needing to move high value assets from one location to another. And it's interesting, having been in this space for quite a while. There's a lot of talk about trying to do this 10, 12, 15 years ago, but you always had challenges with the return of the device because they were expensive and you wanted to return them. And guess what? When you send a package to someone, they returning that piece of hardware may not be the top priority that they have. So the economics were challenged in that. This device here is sub $50 when you're getting them at quantities, and it's disposable. So that whole logistics around getting the device back doesn't come into play. So a lot of interest in this as you deal with logistics to make sure the right things are getting to the right place at the right time. Lastly, we see things happening in the AI area. Everybody probably has their definitions of what AI is going to do in manufacturing. Certainly one of the key things that we see here and why we think it's important, why we're talking about the network today, is it's going to take a lot of data to drive this. So data coming off the IoT devices, the sensors, the cameras, the gateways out there, is you got to move it across some type of network, the whole communication piece, the infrastructure, but then all the AI applications are laying on top of that after you get the data off. That's where you're going to be providing the insights. So, the benefits, you see this, ideally we could, be like, Star Trek and just talk to the computer and say, hey, when's the machine expected to fail next, or what maintenance do we need to do? Exciting area here, as many companies are trying to figure out. But the point of why I'm going to bring this up, and it comes back to this connecting changes everything. When you look at where Industry 4.0 has been and where it's taking us, we're in this, transparency, starting to get more visibility, a lot of things all over the place of where individual companies are at. But the reason, in my opinion, why I wanted to chose this subject to share with you today around wireless technologies is this. And Doug Woods, the president of AMT, they're the industry group that puts on the IMTS show in Chicago every other year. And he is at a session that we were hosting here a couple of years ago, and he had this slide, and it captures the essence of where we're at. this whole thing about transformation, data is going to drive it. And you get more and more data, it's going to put more and more demand on your network. And so, how do all those pieces come together and that you get it? And I think that's what um, application engineers, solution engineers, network engineers just need to be aware that you know we probably haven't seen anything yet as AI continues to take off and there's more data that's fed to it to drive this transformation. So it comes back to things I think I shared a little bit earlier. We look at this from an end-to-end standpoint, and transport's important, but it's not the end result. Sorry, wrong button. Uh, so talked a little bit about that, but around the analytics, and some would just be thinking, big data. We're probably looking at bigger data today. So the part of what AT&T doing, and our group in particular has worked on a number of projects with customers. We've helped with POC concepts of trying to test a concept. Valve company that wanted us to capture data, inbound and outbound to understand potentially how it could be used to reduce warranty claims. We've been involved in end-to-end solutions. This won an award back in 2017 to take commercial food waste at hospitals and cafeterias, etc., that didn't want to put it in the landfill. You grind it up, put it in a container, and a truck comes by and takes it away, and you can make gas out of it and have the byproduct be, feed for livestock. But that is a project that our team has worked on end to end. I think we're in our 53rd change order over almost 10 years now. And lastly, then Red Bull, big project where we connected over 300 coolers globally and involved in proving it out, um, collecting the data. My team dealt with building out or revising a couple of years ago how that data was collected across it, because for Red Bull, the quality of their product was real important. So they monitored temperature closely and a number of door opens and close. So things we've done over the years, a few things that you probably just wouldn't think about AT&T doing. As I come to sort of close out, I'm going to point out just a couple of things. Mention AT&T has been in this business for a long time. A couple of things you may not be aware of. We have over 1.4 million miles of fiber that's installed here in the U.S. Um, if you've tracked much with AT&T over the years, we made a pivot into looking at some media and entertainment businesses. If you were listening to the earnings call earlier today, John Stankey announced that we just finished the full divestiture of some of those assets. And I can assure you that I hear it day in, day out. AT&T is very focused on our roots of getting back to fiber and 5G. If you wanted the fastest description of where AT&T is headed, it is fiber and 5G, really building out those assets and owning it ourselves is what we think is going to make a strategic difference. Um, you know, Not a lot of companies can spend the type of capital that's necessary to build the infrastructure that so many businesses depend on. And the, what is it? Just in the last, I don't know the exact time frame. The number I've given is $140 billion over recent years. I think we're at the tune of 20 to $25 billion a year in investments in our network. So that reflects AT&T's commitment to continue to be out building out the technologies, both the wireless and the wireline side, that help enable all these great, this great digital transformation journey that we're on. So um, that's just a few thoughts there that I wanted to share with you today around why it's important. Data is going to drive this business. It drives us to continue to put new capabilities together to meet the demands of our customers. And so proud to be part of that, and just glad we can share a few of these comments today. I think we do have some time for question and answers. Let me make sure. Yeah. Slide. Let's go this way.
Yay, thanks.
Over
Thanks,
that.
Gillen.
Back
Yeah,
to you.
excellent presentation. You're right, connecting changes everything, and we do expect it to be there. I think you've given us a real good background on understanding the speeds, range, penetration, why it's important. Obviously, we're consumer users, but when manufacturers have to think at a whole different level, and your presentation today really kind of laid it out very importantly and succinct of what we should be paying attention to and why it's important. Obviously, data is driving everything, and understanding what businesses or what business challenge they can solve. So the case studies you shared at the end, thank you so much. This presentation will be distributed after this, so people will get the presentation as well as as the video as well. So we do have a couple of questions that did come in. So what you sort of talked about it. Can we test the technology before using it? You again, you gave us a lot of examples from a $50 disposable, if you buy in quantity, sensor to others. But can you test the technology before using it?
Yes, you can. We have several options available depending on what the needs are. If you're more on the traditional network side, we have a number of centers where we can test out devices. We have some interesting capabilities at the Texas A&M Rellis campus um, around some capability of that campus is actually there's a runway there, an old runway that used to be used by the Army Air Corps. So it gives a lot of space that we can test. We've been there testing bulldozers and forklifts for some of our customers and with some of these newer technologies. We also, as I said, we're testing some things with our Equipment Link offer at Lyft. We also, at one of the sister organizations in Chicago at MXD, we have a wireless test bed that allows to test some things, some of these wireless technologies, and do some comparisons there. So yes, we have a lot of capabilities of how we can help in those areas.
Thank you for that. Um, how quickly do you think we will transition to 6G? I feel like we transitioned in during this presentation from 5G to 6G. I feel like we're there, but what are your thoughts on that?
Yeah. Well, in the slides I'm showing you, that standard is not been written yet. It's in process. So it'll probably be early, 2030s before you see that. And then remember what has to take place. You have to then have the hardware, the radio side of it, and so there's the radio side. There's stuff that AT&T, Verizon, T-Mobile, we have to install things to use these newer technologies. That takes a lot of capital, takes a lot of work to build it out. Once you do that, you then have to have the device manufacturers build the devices they're going to use that technology. And so they have to be able to see the demand for it in order to drive products. And we've seen, well, I've seen actually in several use cases, there's not a lot of products on the business side that are using the high end, the millimeter wave capabilities for very fast, low latency access in the industrial sector. Most are looking at it and communicating data, 4G, the 5G standalone, 5G sub 6 and areas are more than adequate to get the data transported. So I personally think it's going to be several years into that next decade before you're going to see the real benefits on that. Um, and so it's like, if you look at that history, cellular has a much longer runway on things than I think what you've seen in the Wi-Fi world. So nothing to start making plans to make a switch for several years.
I appreciate that. This is, I think, our last question coming in. It's kind of a two-for question. What are the benefits of having a private G network, a 5G network. You kind of talked about that, but and how can we start our own connected infrastructure?
Yeah. So private 5G networks, um, the when you're needing connectivity that has technical capabilities that are not being met with Wi-Fi. So I mentioned, to get coverage with a Wi-Fi network, you have to have a lot of access points. And we've seen customers try to solve the connectivity issue with adding more access points. But that technology does not always allow seamless transition from one access point to another the way the cellular technologies do. So that's one thing, that handoff. So any kind of automated vehicle being used in factories, that might be a use case where you need to think about that handoff. The other part around it is, cellular capabilities just give you much broader coverage. The technology is different, so you can cover uh, a larger area with one radio compared to what it would take to build out that area with Wi-Fi. And then, even as we talked earlier, you have the different choices today, and the 5G mid-band, sub-6 millimeter wave, that all have different characteristics that give you the ability to think about how to construct what your needs are. Now, there can be limitations, right? Um, Physical limitations with the type of equipment there, but the coverage, some may look at it from a security standpoint, and being able to leverage the benefits of cellular in that. So those are just probably two of the examples of how to do that. And how you get started. Certainly you can call me. We can help you with that. But there's others in that area that there's even some ways you can have a test kit come in with CBRS technologies, set it up and test it out. Now it is different. All right, it's not like just being able to take the universal capabilities of a Wi-Fi device and connect it to your Wi-Fi network. You have to think about the SIM cards and the connectivity. But yeah, there's ways to get started and kind of see it and try it out before you make a decision.
Thank you. We did just have one other question come in. What tech shifts should new MVNOs prepare for in the next 2 to 3 years?
What tech shift for the next 2 to 3 years? Wow. Um, what is the things happening? I think in transportation is one. Um, I got to go to the NVIDIA conference out in San Jose back, I believe it was in early March. Um, what struck me is the pace at which AI is changing things and how AI is going to be used in autonomous cars. Um, um, I think it's going to come a lot faster than you think. And I even got a different lesson. My oldest son for Father's Day, he set me up with a Tesla test drive, um, and push the button and the car starts driving itself, and literally drove with several turns and ended up in front of the store that had been programmed to go to it. That made me a believer that self-driving vehicles are coming. They're probably coming faster than we think they are, and you got to be able to have the capabilities to make those communications happen. And so there's a lot that we're doing in that we call it the intelligent transportation system, um, of how cars are going to be connecting and with each other, um, things that we don't know about. So I think that's going to be one of the biggest areas to be preparing for, is how is that going to change the networks and how we operate them and the capabilities we have.
Thank you. Well, that's going to be a wrap today. Those are all the questions that came in. So thank you, Gillen, for a great informative presentation. Connecting does change everything. So I'd like to thank our audience for joining us today. Stay tuned for more webinars and discover more about Lyft and our groundbreaking projects and membership opportunities at Lyft.technology. And mark your calendar for our next Liftoff webinar, which is August 27th, where Lyft member Lockheed Martin is going to be talking about material testing for hypersonics and extreme environments. Thank you, everybody, for joining us today. Have a great day.
Thank you.